now that we've figured out how to solve a system of equations, I'm sure you're thinking, great, but so what? What can I do with it? Well, you're in luck. You can find missing numbers. You can figure out how much mix of cashews and raisins you can combine together to get a certain price. You can do lots of wonderful things with this. And later on, when you deal with more complicated systems, you can figure out how to shoot a missile into another missile and have them explode in air. Really cool stuff. But we're not going to deal with that. We're just going to deal with the sum of two numbers. So we know that a sum of two numbers is 25, and their difference is 7. Find the numbers. Now, okay, I know that the numbers are fairly small in this one. You could figure it out in your head. But we are going to write a system of equations, and then from this system of equations, we are going to find the two numbers. Does anyone know what the two numbers are yet?
Yeah.
Sean?
7 and 18.
7 and 18. So we should get an answer of 7 and 18. Okay? I don't care about the answer. 9 and 16?
That's what I got.
Okay. That's what everyone else got. Okay, 9 and 16. So we know the answer. We don't really care that you know the answer. This is about the process. It's okay, Sean. All right. So we have to break this down into two number sentences. So let's just go ahead and read. The sum. What does sum mean? It's an addition problem. So we have an addition problem. So right now, I'm going to write plus. Oops. I'm going to write plus because it says sum. The sum of two numbers. Do I know what the two numbers are?
No.
So what am I going to use instead of the two numbers? X and Y. Incidentally, could have used B and S. Your initials. Or we could have used H and R. It doesn't really matter. So the sum of two numbers is. Now is a math word. What does is mean? Equals. Equals 25. So we have our first number sentence. Again, this is a system of equations, so we need a second number sentence. And luckily, we find that their difference, what does difference mean? It means subtraction. Their difference is 7. And the numbers are still going to be the same, so it's X and Y. So I have a simple system of equations. What's the easiest way to solve this? Graphing, or substitution, or addition. Brittany? Addition. So let's add straight down. So what is x plus x? So we have 2x. Y minus y? 0. It cancels out. 25 and 7. So 2x is equal to 32. Great. What am I going to do to both sides to get the x by itself? Divide by 2. So I get x is equal to, which is what we said in the first place. So then let's plug that in here. So if x is 16, we have 16 minus y is equal to 7. Well, 16 minus what is 7? This one's really tough here. 16 minus what number is 7? 9. Okay, so y is equal to 9. All right, so we found the two numbers. So all we had to do was to write two math sentences and solve the system. That's not too difficult, is it? Let's take another one. Michael has $84 less than 3 times as much as Jenna. Go figure. Together they have $132. How much does Michael have? Okay, this is the same type of problem. We are being asked to solve a system of equations, but instead of giving us the equations, they give us a nice little word problem that we need to translate into math. So let's translate, shall we? Yeah. Just a reminder, if I think it's important enough to write it down, you think it's important enough to write it down. So Michael has $84 less. What does less mean? Less? What mathematical operation? It's a subtraction. So we have then 3 times as much as Jenna. So how many? 3, so we have a 3 times. And our variables here are going to be M for Michael and J for Jenna. So what are we going to multiply 3 by? And I'll reread the sentence. It says, Michael has $84 less than 3 times as much as Jenna.
J. We should multiply it by J.
So 3 times Jenna equals Michael. All right, let's take a look at the next one. Then it says together they have $132. What's it telling you to do when together they have $132? They're telling you to add. So what are they adding?
Michael's Jenna.
All right. And that is equal to 132. All right. Which method of solving this system is going to be the easiest? Is it going to be multiplication and addition? Is it going to be substitution? Is it going to be by graphing? Ethan?
Substitution.
This is going to be one where substitution is easiest. So, what variable are we going to use as our substitution vehicle?
Well,
Jenna?
M is already by itself.
M is already by itself. Jenna is saying her brother is already all by himself. Okay. So instead of M, what am I going to write?
3J minus
3J minus. Okay. So we have J plus 3J minus 84 is equal to 132. Okay. What am I going to do next? Brandon? Combine the J's. So J plus 3J is 4J minus 84 is equal to 132. So now what will I do, Ethan?
Add 84.
Add 84. So when I add 84 to both sides, I get 4J is equal to
16.
That's convenient because I know 4 goes into 216. So now I divide both sides by 4 to learn that Jenna has $54. All right, so now let's figure out how much Michael has. So what am I going to do?
plug 54 into the top equation.
I could plug 54 into the top equation, but that would require slightly more work. So I am going to plug it into the...
I just subtracted 54 for 132.
Yeah, we subtracted, yeah. But yes, as we should follow the correct process. So we're going to plug this number in to this equation. So we have 54 plus m is equal to 132. And as Betsy pointed out, really all we have to do is subtract 54 from both sides. And I find that Michael has
78. So this is an unrealistic problem.
Yes, very much so.
Very much.
So this is truly unrealistic. Okay. Are there any questions? All right. Last one for your solving word problems using systems of equations pleasures is Elvis Cinema charges $5 for an adult and $2 for a child. Last weekend, they sold 785 tickets to The Life of Pi for $3,280. How many kids saw the movie last week? Of course, you're probably sitting at your desk. Why didn't they just count them when they sold it? But they forgot. So Idiots, yes. So let's turn this English sentence into a mathematical system of equations. Now, this one we're probably not going to go through and solve all the way. We're just going to translate into mathematical notation, and then you can solve it at your leisure. All right, so does anyone see one equation that they could write from this text? Colton?
Use A for adult, C for child.
So we're using A and C.
A plus C equals 7.5. Where that counting?
Okay. Because if you add the adult and the kids' tickets sold, you get the total number of tickets sold. Okay. Is there another equation that I could write based on this text?
5a plus 2c equals 3,280.
So 5a plus 2c is equal to 3,280. Now, why does this make sense, Sean?
Because that's the total price, and it's $5 for an adult and $2 for a kid. So add them up when you get total.
Okay. So this part of the equation represents how much money you earned on the adults. This part of the equation tells you how much you earned from the children's tickets. So now you have your system. Incidentally, what would you probably use? Substitution or multiplication addition in this problem? Probably multiplication addition. I'd probably multiply the top equation by -2. Okay. So are there any questions on translating English into mathematics?